Now let the area bounded by the curve y equal to x square plus 1. This is clearly a parabola open upwards, cutting y-axis at 0, 1, right? And the line x equal to y, and the pair of lines x square plus y square plus 2xy plus minus 4x minus 3y plus 3 equal to 0. If you observe the pair of lines x square plus y square plus 2xy minus 4x minus 4y plus 3 equal to 0, as the second degree terms are making a perfect square, that's a pair of parallel lines, and clearly the two lines are given by x plus y minus 3 into x plus y minus 1 equal to 0, right? So the area bounded by the curve y equal to x square plus 1 and the line y equal to x and the two lines x plus y minus 1 equal to 0 and x plus y minus 3 equal to 0 is given to be A. This is already given to us. Now what is required? The area bounded by y equal to x square plus 1, the same curve, and the curve y equal to square root of x minus 1 between the same lines x plus y minus 1 equal to 0 and x plus y minus 3 equal to 0. Now here there is an interesting fact. What can you say about this curve y equal to square root of x minus 1? Yes, when you consider the curve y equal to x square plus 1, can we write the inverse of this function? Yes, in that case x square would become y minus 1, or x would be square root of y minus 1. Therefore, when x expressed in terms of y, so f inverse of x would be square root of x minus 1. So this is a very important observation. The second curve with which we need the area between the same lines and the curve x square plus 1 and the curve y equal to root of x minus 1 is nothing but the area bounded by the given curve with its inverse between the same pair of lines, right? Now here if you observe y equal to f of x and the other curve y equal to f inverse x are clearly the mirror images of each other with respect to the line mirror y equal to x. So how will be the graph now? If this is the graph y equal to x square plus 1, then the graph y equal to square root of x minus 1 would be the mirror image of this line with respect to x equal to y, right? And the two limits are same. So what can we say now? Therefore, area bounded by y equal to square root of x minus 1 with the line y equal to x and the lines x plus y minus 1 equal to 0 and x plus y minus 3 equal to 0. This area would also be equal to A, right? So area above the line x equal to y and the area with respect to y equal to square root of x minus 1 are both equal. Now what is our requirement? Therefore, the area bounded by first curve y equal to x square plus 1, y equal to square root of x minus 1 and the lines x plus y minus 1 equal to 0 and x plus y minus 3 equal to 0. This total area would be equal to the first area A plus the area below the line y equal to x. That means that is also A. So this total area would be twice that of the area bounded by y equal to x with the curve y equal to x square plus 1, right? So which option is that? It is 2A. It doesn't require any of the integration process, but we only require to identify that the inverse of a graph is required for the second function, and the inverse will always be mirror image of the original function with respect to the line x equal to y. Once we identify this process that the second function given is the image of the first function, then the problem is quite simple.